All right, all right, all right. We are doing a problem again. um, we're we're gonna be visiting a problem that's very similar to the one that was done yesterday. I'm not picking these in any specific order. This just happens to be, the next one on the list. So we are here. Rearrange string k distance apart. Given a string s and an integer k, rearrange s such that the same characters are at least distance k from each other. If it is not possible to rearrange a string, return an empty string. The empty string. Um, so basically, even though you see the distance is like 3, it's actually they just need to have two characters apart from each other. Like you calculate the actual distance from like the two of the same character, right? So if it's 3, you only need 2 in between them in order. I don't know. I don't know. For me, at least logically speaking, it doesn't make a lot of sense, but that's just how the problem is. So for me, in my head, a distance of 3 is more like a distance of 2. But yeah, so without much being said, we can just go straight into it. So if k is, we're gonna have an edge case where k is less than 1, then we just return s because well, since you only need one distance in between, and then since the distance is calculated by the same character, so an a and a next to each other with a k of 1 would be a valid string. So we don't need to do any um rearranging because even like if k is 1 and it's all the same character throughout the whole string, it's a valid string, right? So that's all we need to do for that. And then so it's basically the same thing as yesterday. So we create a dictionary, and then for character and string, we're going to do dict character is equal to dict.get the character or 0 plus 1. So that's how we build like our, what do I call it? Um, our our dictionary are like essentially counts, right? Like for every character, like the counts that we have. And I forgot a few of the imports, so we're going to be using heap cube because this is a what is it? A top k problem. So we're going to be using heap cube. I'm going to import all just so I don't have to do heap q dot heap push or stuff like that. And also from collections, we're going to import deque. We're going to be using the deque in order to implement this integer k part, because if you saw the video from yesterday, you'll see that we didn't use a deque. We just held the previous one and then put it in afterward just so we could follow the rule of, I guess, in a sense, would be this problem k equals 2, right? So yeah, so after we build the counts here, we're going to initialize a max heap, which is just an empty array for a key value in dict.items. We're going to do heap push max heap negative of the value because we want a max heap and the key. And then if you see in my other videos, like typically when I do this, I do k comma v, but later when you see in my submissions, or actually I can just show you now, I got a wrong answer because I used k here, but that overrides this, so that's not what we want. So I have to explicitly say key and value this time. So after that, we're gonna build a result. I think yesterday I did it by string, but thinking more about it, since strings are immutable, you can only like change the reference. Putting it into a list and then doing a dot join at the end will be better, because the time complexity that's essentially implied by doing a plus equals on a string is a lot worse. So we're going to change that up for today. And we're going to initialize a deque as well, because we're going to create a queue, right? And then for whatever distance k it is, we'll just have essentially that many items in our queue. So same thing as yesterday. While max heap, this just means like the length is greater than 0. You could explicitly state it as well. We're going to extract the frequency and character from max heap here, and then we're going to do result.append the character. Now, here yesterday we just well, I guess technically here we did like the whole put previous character and frequency onto the max heap, right? But today we need to put it onto the queue, and we don't need to put it on like right after we pop. I mean, yesterday we didn't need to put it on right after we pop either, but here we need to essentially check to see if we have to put anything back onto our heap. So we're going to do a queue.append and put a second layer of parentheses. We're going to do the character plus frequency plus 1, because since we're doing negative frequencies for our max heap, doing plus 1 will take us closer to 0 as opposed to minus 1, right? And so now we need to check if the length of q is equal to k. Then that means we have the perfect distance of perfect distance between the unique characters now. So whatever's at the front of the array, when it was added, there's enough characters in between to satisfy the k distance, so we were able to pop that off. And since obviously we don't know during runtime what the character is, we can't say what it is. So we'll just do a previous character and previous frequency is equal to q dot pop left, right? So now we take off the left side of the queue, and if previous frequency does not equal to 0, you're going to want to do a heap push onto max heap with previous frequency and previous character. And then this will have enough to get you through the while loop, and so you could potentially, perfectly, what do I call it? Build the string, and so return the empty string dot join result if the length of result, this is the same thing as yesterday, right, is equal to the length of s, else the empty string, right? Because this is a little bit different because we're putting it into an array or list, and we're building out the solution building out the string afterward, right? So that's how you can create the string from the result array. And so basically, if we get repeating characters before the length of q equals k, well, we won't push anything back onto the max heap, right? So eventually, we'll run out of things in the max heap, and we won't build out a result that's equal to the length of s. So that's how we get like essentially this empty string case, right? So yeah, that's how you would do this problem. I did talk a lot about the video yesterday, which is just rearrange string. I'll put like, what is it, one of those info cards at the top for like, I don't know, maybe like the first minute of this video or something like that. So you probably want to go watch that first. I explained the problem a lot more. But yeah, that's just how I would do this problem. And yeah, thanks for watching.